Lesson 14.15, solving half-life / doubling functions. Same thing on the previous lesson, just knowing that when we're having half-life or doubling, it's either times 0.5 or times 2, and then we have to have our power be a fraction. Number 1 says element X, it's a radioactive isotope such that every 94 years its mass decreases by half. So that's a half-life. Given that the initial mass is 410 grams, how long would it be until the mass reached 350 grams to the nearest tenth of a year? So we want to put what it started with, which was 410, its initial mass, times its growth or decay rate, which is it's decreasing by a half, so think of 50%, and then that's really 0.5, so 1 minus 0.5 is 0.5, or just think it's half of what it was. And then it's not decreasing that every year, it's going to decrease that every 94 years. So if my time was 94 years, 94 divided by 94 would mean it's going to cut in half once. So I have to have that as a fraction, and it wants to know after what time is it going to reach 350 grams. And so our same process here is get the exponential part by itself. So I would divide away the 410. Which is that number. Rewrite this as a log with a base of 0.5 of this 0.8537 number equals t getting divided by 94. This is change of base here. So I'm going to do log of second answer divided by log of 0.5 gets me that. But again, don't erase that out of your calculator. And then the only other thing I need to do to get t by itself here is multiply by the 94. And I get that. So nearest tenth of a year be 21.5. All right, number 2, we got a lab experiment. 60 bacteria are placed in a petri dish. The conditions are such that the number of bacteria is able to double every 12 hours. How long would it be to the nearest tenth of an hour until there are 151 bacteria present? So it starts with 60 bacteria. It's doubling, so that's like 200% or times 2 every 12 hours. So not every hour, but every 12. So it's time divided by 12, because if it was for 12 hours, 12 divided by 12 would be once. It's going to double. How long would it be till there's 151 as your total bacteria? So we need to divide away the 60. 151 divided by 60 is about 2.5167. Change this into a log. Base is 2 of this number equals t divided by 12. And you could leave this fraction here if you wanted to. Might make it easier. Do change a base right here to get this to be a number. So log of second answer divided by log of 2. Oop, I didn't do divided. Gets me about 1.3315 is equal to time divided by 12 to get t by itself multiplied by 12. And it said to the nearest tenth. So that 7 actually makes the 9 round up to a 10, which rolls over to make 15 become 16 years. And that's it.